lesson 3.2, implicit differentiation. So we've been working with what? With functions like y equals, say, x squared plus 4x plus 3. That is a quadratic equation. You can apply the power rule and take the derivative of something like this because it is a function. So y equals f of x. So you can just say f prime of x is equal to 2x plus 4. Because it is a function. But when it's not a function, for example, if you have something like this, what is that if I was to graph it? Anybody? Did you guys take geometry? Did you guys take trigonometry? Somebody said no because we did. So anyways, this is a circle centered at 0, 0. So it's centered at 0, 0 with the radius of what? The general equation of a circle is x squared plus y squared equals r squared. So then the radius will be 2. So this is a circle. So it's not a function. So we're going back to the idea of what is a function, what is a not a function. This is not a function, but cross it. There's no unique output for a input for, like, say. So this is not a function. Then you got some what are they? Ellipsis. You got ellipsis and all those other functions that you did in trigonometry. But in any case, you apply implicit differentiation when you have to differentiate both sides that have x's and y's. Okay, so here's an example. That is a circle. If you have x squared plus y squared equals 25, you have a circle with a radius of 5, then how do you find dy dx? What you do is you take the derivative of both sides. So I guess we're not going to do that one. Or we should. Let me do that. Let me do this one. Let me do this. So x squared plus y squared equals 25. You're going to take the derivative of both sides, or take the derivative of the whole thing. D dx. Okay. So what's the derivative of x squared? 2x. And here's where it's going to get confusing for some people, and this is the hardest part. What's the derivative of y squared? What would be the derivative of y squared? Well, it will be, see, you just have to remember, you can go ahead and apply the same thing here. It will be 2y, but we're differentiating this y with respect to x. Whereas here, is it going to make any sense? See, what we're doing here, dx of x squared, when we're just looking at that like that, dx of x squared, really it is this. It's the derivative of x squared is 2x, but we always are supposed to put something here that is dx, change of x with respect to x. So dx over d change of x with respect to x, it's like 1, or it's not there. So that's why we never even talk about this stuff here. Whereas when we have something here, dx of y squared, we're going to say the derivative of this is 2y, but we're going to say the change in y with respect to x. So 2y dy dx. So we need to understand this. So when we write this over here, we're going to say d dx of this is definitely 2x. dx dx, which is 1 or nothing. Then this is going to be 2y dy dx. That's what we need to do. And then it's like we're doing this, and the derivative of 25. What's the derivative of 25? 0. Now we can go ahead and solve for dy dx. We got to solve for this dy dx. How do we solve for this dy dx? It's just algebra now. Come on. Somebody say minus 2x to the other side. We want to get the dy dx by itself. So we're going to get what? Let's go 2y dy dx is going to equal to negative 2x. And then how do I get the dy dx by itself now? Divided by 2y. So we're going to get dy dx is equal to negative x over y. All right. So here on this example, I guess here's another example. I guess I could work it out. Let's work it out just the same. I'm already getting ahead of the actual lesson or whatever. So we're going to find dy dx for this function. Is it's not a function because let's see. If I was to graph it, it wouldn't be a function for the same reason I just talked before. So we're going to have to take the derivative of both sides. Let's not do this. Let's just go to the lesson. So it is mostly for problems that are not functions. All right, so let's go ahead and get started with the implicit differentiation. Did I not already do it? I already did it, problem number 1. I already did it. So let's redo it. What are the steps? Maybe this is better if I give you steps. Step number 1. Take the derivative of both sides. Write down d dx on both sides of the equation. I guess this could be more structured for you. We're taking the derivative of both sides. Distribute d dx to each one of the terms. Take the derivative of each one of the terms. That's what it's saying. And take the derivative of each one of the terms. We already did that. Yeah, this is more structured, I guess. Take the derivative of each term. The derivative of x squared is 2x dx dx, which dx dx is we don't ever write down the exchange of x with respect to x, that's why. But we do have here, whenever it's a different variable with respect to what we're differentiating with, so it's going to be 2y dy dx, and this is 0. And we just solve for dy dx. Is this the one also that was on the example? Yeah, let's go ahead and do this then. Find dy dx. I'm gonna get on this video and somebody from AP who watches it, they're so like specific about how you answer questions, and gets on my nerves. Like, in any case, I don't even know if like they'll be like, that's not proper. I'm gonna take d dx of the whole thing. D dx of the whole thing. Let's go ahead and just do like weird looking d. Let me see. D dx of this whole thing. All right, let's go. I already pretty much presented everything you need to know. It's just let's do it now. Let's go. What's the derivative of this first term? 3x squared, knowing that it's dx is whatever, like that. All right. So now, are we gonna do the product rule here? Product rule? Yes, we are gonna do the product rule. All right, let's do it. What's the product rule? How does it go? Product rule. The first times what? The derivative of the second. So what is the derivative of the second? 2y what? Yes. That's the main lesson for today. Oh, did I say T? Is to remember this. This dy dx. Yes. The first times the derivative of the second plus what? The second times the derivative of the first is just 1, isn't it? Let me just write it. Okay, and then plus what? Plus what? What is it, Vivian? 4y to the power of what? 3, then what? dy dx. It is going to equal to what? 0? Pretty much now, it's all algebra. We've already done the calculus here. All this now is algebra. How do we get the dy dx to be by itself? So can we just like move 3x squared and y squared over to the other side? That's what I'm going to do. All right. So, and I'm going to keep this term and this term on this side. All right, let's do that. So x, I'm going to put 2 in front of x. 2 xy dy dx. And then we're going to put that one over there also here next to it. 4y cubed dy dx equal, I'm going to move this over and I'm going to move this one over. So that's going to be negative 3x squared and move it over minus y squared. Now how do I get the dy? Did I write down dx? What am I doing? What am I doing? dy. What? dy dx. Okay. 2xy dy dx. All right. How do I get the dy dx to be by itself? Just somebody say factor. Can you factor out dy dx? Yes, you can factor out dy dx. So let's factor out the dy dx. If I factor out the dy dx, then what's going to be left over then? 2xy plus 4y cubed. Yes. And now we've gotten this one by itself, the dy dx. So what would be the final step? Divided by this thing and get rid of it. So there's the answer right there. dy dx is negative 3x squared minus y squared over that thing right there. Alright, let's see if I can improve my writing and not make so many mistakes on the next problem. Let's see. Um, whatever, same answer. Just factor out the negative here, just in case they have it, but they're both the same answer. Let's go to number 3 then. What is dy dx at the point 2, 8? Let's see if we can improve my writing here. So we're going to take the derivative of both sides. D dx so what's the derivative of x? 1. What's the answer to the second? What's a third of 3? 1. Then we got what? Y to the what? 1/3 minus 3/3, which is going to be y to the negative 2/3. Which, what are we going to do? What are we going to do? And take it to the bottom? I don't know. Let's go ahead and leave it like that, no? Let's go with plus y to the negative 2/3. And I better not forget what? Dy dx equal what? Equal what? Dy dx, no? Just dy dx. Solve for dy dx. Let's see here. How do we get the dy dx by itself? How do we get the dy dx by itself here? Well, you're going to have to do a lot of algebra, no? So, what are we going to do? Yeah, we're going to have to move it to one side. Let's move the whole quantity here, this whole quantity, to the right side. So I'm going to minus y to the negative 2/3 dy dx to both sides. I don't know, I'm doing a lot of writing here, but let's go. I'm going to minus it to the other side, the whole term. So then that thing cancels, so you're going to get 1 equals, 1 is going to equal to dy dx minus, did I forget negative here for this one? Y to the negative 2/3 dy dx. Then we can do what we did in the other problem, is what? What's the word? Factor it out. Yes. So that's going to be 1 is going to equal to, 1 is going to equal to what? Dy dx. And what's going to be left off? 1. And we can divide that over to the other side. Yes? So dy dx is going to equal to that. We got the dy dx by itself now. What is it asking us to do now that we got the dy dx by itself? Evaluate it at the point what? X and y. X is 2, y is 8, no? So the way they do that is just they draw a line and they just put the 2, 8 here. Evaluate it at that 2, 8. Meaning that we're going to plug it into, well, there's no x, so we don't care about the x. We're only going to plug it in for y here because there's no x's. So it's going to be 1 over 1 minus y is 8 to the negative 2/3 power. All right, so it's going to be 1 over 1 minus. What's the cube root? This is the cube root of 8. What's the cube root of 8? 2, and then 2 to the negative 2 power is what? 1/4. Is that 1/4? So this is going to be 1 over. What is $1 take away a quarter? 75 cents, which is 3/4, no? And so what's $1 divided by 3/4? No, why would it? No, that's fine. No, we're subtract 1 minus. We did that 1 minus and we all did all that. Because it's fine. What's 1 divided by 3/4? Is it 4 over 3? It isn't 4 over 3. No? It is. Yeah, 4 over 3. So it's 4/3. Yes. Is that correct? Make sense? I don't know. Something else. But it's the same answer, no? We did it different. Let's go number 4 then. What do you guys do number 4? Let's do one by yourself then. If is that then at the point 21 dy dx equals same kind of question as number 3, written differently, I guess. Let's get going with this. D dx. What is it? Come on, let's get going with this. What is it? Do it together. 2x. Product rule, no? First times the derivative of second is what? Dy dx. Plus the second times 1. I'm not even going to put that down, right? Okay. Minus what? 3 what? 3y dx. 3 dy dx. 3 dy dx equals 0. Yep. Move the 2x over to the other side, minus 2x, minus y. And I'm already going to factor out the dy dx. X minus 3, negative 2x minus y. Divided by x minus 3. Dy dx is going to equal 2. Evaluate at what? 2, 1. Can I already go here? 2, 1. So x and y. X is 2 minus 3. Negative 5 over negative. Is it? But is it or is it not? All right. Yes, move on. Next. Okay. Some trig. Given that 3x minus tan y equals 4, what is dy dx in terms of y? What? Alright. D dx. Tan y. The whole thing. Let's see. So this can be 3. What's the derivative of tangent? It's secant squared. It was secant squared. So it's going to be minus secant squared y. Then what? Dy dx. Equals 0. Solve for dy dx. Okay, minus 3. Well, minus 3 to the other side. Negative secant squared y dy dx equals negative 3 divided by negative secant squared y divided by negative secant squared y dy dx is equal to negative divided by negative is a positive. Hold down here a second. Well, it's going to be a positive because that's a negative divided by a negative is a positive, positive. 3. But what is what's secant? Secant theta, whatever. What is that equal to? What's the reciprocal function of secant? Isn't it cosine? 1 over. Hold on, but it's already under it, no? So it's under. So if it's 1 over secant, it's gonna be now what? Cosine. Yeah? Yes. So this should be what? Cosine squared y? Yes. We'll finish, I think, with this. You get the idea of it. Let's finish with number 6 here. Why are there so many people missing again? PSAT? Huh?
The military one. I don't know what's called.
Oh, ASVAB? Anthony, where do you go take that PSAT?
Huh?
Where do you go take that? There's also that PSAT, I think, today. For 10th graders, I think. Find y prime. If x to the third plus y to the third equals 6xy, then find the equation of tangent line at point 33. All right. So this is what's that called? They ask this question so much. So we got what, x and y, so x minus 3, y minus 3. The problem will be this. Find the slope at that point. All right. Let's do the ddx of this whole thing. ddx of this. ddx of that. 3x squared plus 3y squared dy dx this is going to be the product rule. I'm going to assign the 6 to be with the x. So, and keep it like that all throughout the process. The first times the derivative of the second, dy dx, plus the second times the derivative of the first. What's the derivative of the first? 6. Yes? Because I'm calling that to be look, I'm gonna do something else right now. If this was like a multiple choice question, and all you needed to do is figure out if this is a multiple choice, if it's like B or whatever, and you need to find N, you can already go ahead and substitute in x is 3, y is 3 into this thing before solving dy dx. Let's do it like that, like what I'm saying, to speed it up. 3x is 3 squared plus 3, y is 3 squared dy dx equals 6 times 3 dy dx plus y is 3 times a 6. 3 times 6, I'm trying to, and then this is going to be what? 3 squared is 9 times 3, 27. 9, 27 plus 27. Yeah? Dy dx times dy dx. 18 dy dx. 18. I'm going to minus 27 to the other side. Minus 27 to the other side. Minus this to this side, yes? Which is what? Is that 9 dx? 9 dx? dy dx? So it's going to be 9 dy dx is equal to negative 9. What? Is this dy dx equals negative 1? Yeah? Yes or no? I hope I did it right. But I'm trying to show you, like, sometimes you can speed it up depending on what the question is. If it's an FRQ, like I just said, those people, they're like, they like it their own way. But anyways. Did I get positive 1 or negative 1? Yeah. All right. I think that's it, love. You get the idea?